Good morning. Again we are going to continue our class, and we have detailedly seen in the previous classes about electrostatics. Today we are going to see about current electricity. So the word current electricity is a second chapter. In this chapter we are going to say about the current electricity, definition of current, why this chapter is separated from electrostatics, how we can find Ohm's law, what are the failures of Ohm's law, how it can be modified by some other law, what are electric cells, how the current measurement and solving problem. Very small unit. So in this chapter, some maximum question, usually once we know IIEEE, so most engineering classes, the question maybe comes, and also some power problem maybe comes in NEET and other MBBS, that is medical oriented classes. Electric current, what is called current? Generally we know what is the definition of current. What is current? Immediately you are saying it is a flow of charge. That is wrong. The literary meaning of current means flow, that's all. What is current? Current means flow, that's all. What is electric current? Electric current only the flow of charge. Generally, we discussed in the previous lesson itself, what are conductors? Conductors are one which can allow the charges to pass through it. The same thing, we have to think it up, entire chapters, this definition. Conductors are one in which free electrons are moving. Then only it is possible to conduct electricity. Conductors are one in which free electrons are moving. Since they are free, they are in random motion. They are in random motion. When they are in random motion, they collide with each other. Am I correct? Energy can neither be created nor be destroyed. How much energy decreases, dissipated as heat. This is the history of usual any conductor. What is the electric current? The rate of flow of net charge through a cross section of some region, say metallic wire. Take any wire, copper, nickel, whatever may be the wire available. In that particular metallic wire, what is the current? The current, average current is always equal to how much is the charge flowing through it in a time difference delta T. I average is equal to delta Q by delta T. Otherwise, what is the instantaneous current? For a particular time, what is the current? That is dQ by dt. In general definition, we can write reversal, that is nothing but rate of change of charge. That means the charge flowing through the conductor, or the charge divided by time, that will give current. So be careful, in order to calculate the current, I is equal to dQ by dt. Why I am saying that? That may be very important for us, because the current is nothing but the total charge flowing divided by time taken. This is generally we know. The instantaneous current for a particular thing, I is equal to rate of change of charge. That is dQ by dt. So from which we can able to find out dQ is nothing but I into dt. This is a general formula. So we want to find out how much charge it is. So we have to integrate it. If you integrate it, integral of dQ become Q, that is I into dt. This is the reverse formula for the determination of charge. What do you infer from this? It is clear that if once we know the charge, we can able to find out the current. That means we have to differentiate the charge to find the current. So if we are given the current, we can able to find out the charge. How? We have to integrate it with respect to time. Here differentiate with respect to time, we will get the current. or integrate with respect to time, we can able to get the charge. This is a reverse concept. So most of the JIPMER and other medical entrance examination, these are the formula you have to understand. We have to integrate it. In order to integrate it, we can obtain charge. In order to differentiate it, we can obtain current. That is a keep your mind. So that is the thing I have given here. I is equal to dq by dt. What is the unit of current? Ampere generally. You know charge coulomb by time or ampere. The direction of the current is taken as the direction in which positive charge moves. What is it? That is the thing I want to explain it. Usually, current is a dash quantity. What is your answer? In the entrance examination, once there is different, nowadays the latest syllabus, the current is a dash quantity, which is the correct answer. The correct answer is a scalar quantity because we may not know what is actual direction of the current. By way of external agency only, we can judge the direction of the current. Therefore, the current is a scalar quantity. Then how can you find out the direction of the current? That direction is called conventional direction. That is, the word given is called conventional direction. What is convention? We are assuming that you should not ask question why it is. So every day we are cleaning the entrance of our house. What is the reason? We don't know. Because our parents are doing, we are continuing the same. We are celebrating so many festivals like that. Because we are celebrating the festival by the followers of the elders. So just like that, that is called convention. By convention only we are doing like that. The conventional direction of the current, how can you? It is only a convention because it is not visible. But take a conductor. I take a conductor, copper wire or anything. This copper wire is connected to the external potential difference. Be careful. This external potential difference we call as EMF. What is called EMF? The word is very important. EMF, electromotive force. What is the motive of this force is given? So even though it is a force, but it is not a force. Be careful. Electromotive force is the amount of work done in moving a unit charge from one end of the conductor to the another. So we have to move a charge from one end of the conductor to another end. So we have to do some work. That work done is nothing but EMF. EMF only by the external closed circuit. Then only we are having EMF. So it is connected to the EMF. One important question we know, take a copper wire on the road, or you can keep the copper wire in your hand. Even though it is a conductor in which free electrons are more, they are in motion, we are not getting any current there. What is the reason? Because if you are touching the copper wire, the current flow for a particular point is zero because current random motion it goes. If it is in random motion, we cannot have the current. We cannot judge the direction. So that in order to make the electron in a particular direction, the external force is needed. That the external force is called electromotive force. Even though it is a force, it is not a force amount of work done. You have to keep your mind. So like that, this is a wire, copper wire, a full conductor. So without a external agency EMF E, the electrons are in random motion. We cannot judge the direction. As soon as the electric field is switched on, this is the direction of the current. Direction of the current is always higher potential to lower potential. That is positive charge to negative charge. This is the current flow. So all the electrons, we know electrons having negatively charged, these electrons are moving towards the positive terminal. So this is the direction of motion of electron. This is the direction of motion of the current. What do you infer from this circuit? It is clear that the direction of current is nothing but opposite to the flow of electron. Usually the current direction always opposite to the direction of flow of electron. Otherwise, it is the direction in which a positive charge flows. That is also correct. So we have to take like that. So how can you take, how can you boldly say the current is always from this? There is a conventional direction. That is a thing. That is a thing you have to understand it. Because it is a conventional direction, the pure current is a scalar quantity. So this EMF plays an important role. So wherever there is a conductor, free electrons are more, they are free in random motion. But by the application of external agency called electromotive force, all the electrons are moving in the definite direction. That means particular direction towards the positive terminal. They produce a current. That is the thing we have to understand it. From this only you have to keep your mind. The same diagram, what is the drift velocity? The drift velocity, you have to keep your mind. So without an external agency or without an electromotive force, the electrons are in random motion, definitely. As soon as the electric field is switched on, already electron in motion, because of the external electric force, there is a sudden increase in velocity. This sudden increase in velocity called drift velocity. The sudden increase in velocity is lapse only as far as the external force is there. If you are removing the external force, automatically the drift velocity also changes. So there is a sudden increase in velocity is called drift velocity. So how can you find the answer for that? So very simple. So without an electric force, we know by Newton's law, F is equal to ma. Here F is equal to E into E. Why? Because capital E is the electric field, small e is the charge of an electron, charge into field will give force. We already know. Therefore, the value of ma is equal to E. Therefore, A is equal to E by M. So this is the acceleration. Such a acceleration, the electrons are in motion. So once we know acceleration, that should be multiplied by time, we are getting velocity. Therefore, A into tau is called velocity Vd, that is equal to E by M into tau. What is called tau? Tau is called time. That is called relaxation time. Tau, where tau is called relaxation time. So relaxation plays an important role. What is the meaning of relaxation? If you are continuously studying, get tired, somebody says kindly relax it. Relax means the change of activity itself called relax. We need not go and flatten. If you are flattened, that is called permanent rest. There is a lot of difference between rest and relax. Relax means change of activity. If you are doing physics problem, you are getting tired means we have to change the subject. Go to mathematics or zoology. If you are changing, or even though you are having more tired, we can see 5 or 10 minutes a good film or good songs you can hear. That is a change of activity itself is called relaxation. This relaxation time, that is acceleration into time, that will give velocity. Therefore, Vd is equal to E by M into tau, where tau is called relaxation time. Relaxation time is very, very small. In most of the entrance examination, what is the value of relaxation time they ask? If they ask, you can boldly put 10 power minus 14 seconds. That is called relaxation time. 10 power minus 14 second is called relaxation time. Substitute the value. What is the value of drift velocity? Simply 10 power minus 4 meter per second. 10 power 4 meter per second. This is the drift velocity value. This 10 power minus 14 second is called, what is that? That is called relaxation time. So these are the things you have to keep your mind. That is given in the slides. The direction of current is taken as the direction in which positive charges are motion. Electromotive force, just now I have given, it is the work done for a unit charge in taking a positive charge through the low potential end to the high potential end. We have to, current is always flowing from higher potential to lower potential. If we move in the reverse direction, we have to do some work. That work done is called electromotive force or EMF. That is epsilon or E is equal to W by Q. This is a formula also I have given. So electromotive force can be calculated work done divided by a charge, unit charge, because the definition itself unit charge means total work done is W, that will be divided by a charge, that will give the EMF. When no current flows through the flows, for example, the EMF of the source is equal to potential difference. There is a difference, we have to understand it. So, the potential difference and the EMF all are same. Only one difference is, if current flows, we should call as EMF. If no current flows, we should call as potential difference. Unit is always volt. Just now we have seen what is drift velocity, the average velocity with which the electrons move in a conductor under a external agency. So I have given the derivation. And also, I want to discuss now. The drift velocity, just now I have given the formula, P suffix D is equal to E by M into tau. But take this Vd, this E comes here, that is equal to E by M into tau. This is called mu, so be careful. What is Vd by E? This is drift velocity acting for unit electric field. Drift velocity acting on unit electric field is called mobility. This mu can be called as mobility. This electron mobility, since electron has in motion, that is called mobility. So when you go to your dental doctor, some teeth will be shaken. So they are using the word, your teeth are mobile or mobility. So some mobility is there. Mobility means not at rest. So the mobility, since electron has its mobility not at rest, the entire chapter electronics will be invented in future. Be careful. So electron has its own mobility. What is mobility? Drift velocity acting on unit electric field is called mobility. How can be calculated? By using this formula, E by M into tau. What is called E? Charge of an electron. M, mass of an electron. Tau, the relaxation time. Substitute this, the mobility can be calculated. This is the one thing I have to remember. So another one is called, what is charge density? J. J is called charge density. The charge density is a vector quantity, don't forget it. Current or current density, charge density, other it is called current density, that is best. We should not use charge, we can use current density, the crowd of current. The current density is a vector quantity. What is a current density? Current acting on unit area is called current density, that is J vector, that is IA. But I is a scalar, from which also we can able to find out I is equal to J dot A. Be careful, there is a dot product. So from each current density we can able to find out the current, from the current we can able to find out the current density. So these are given in this. Now is the relaxation time, 10 power minus 14 second, that is not here, yes, second. Vd 10 power minus 4 meter per second. Then we can pass on to the Ohm's law, very important law. I will discuss more the Ohm's law. Ohm's law, very important law. So in lower standard, you are confused yourself about the Ohm's law. From the Ohm's law, so many formula comes. That is not a Ohm's law. The Ohm's law should be started as Ohm's started. Because we know the relation between the current and drift velocity. I is always equal to NAEVD. Be careful. This is the relation between current and drift velocity. It is not a Ohm's law. The relation between the current and drift velocity. What is N? We have to keep more constant on N. N is the number of charges or electrons flowing per unit volume. Don't forget it. Unit volume. where n is the number of electrons or charges flowing per unit to volume. If volume is 1, number of electrons flowing small n. That is the thing we have to understand it. For the volume, particular volume, we have to multiply it. Where A is called the area of cross section of a conductor, E charge of a single electron, Vd is the drift velocity. So here I have to concentrate it is I is equal to Na E, Vd just now E by m into tau. So what is called E? E is always V by D. We know V is equal to dV by dr. Therefore I becomes Na E square simply E V by D into tau, or I proportional to V. From this we can arrive, because Na E squared D and tau are constant here. Why? Because number A, charge of an electron, distance between the two metal plates, or tau, everything is a constant. Therefore, the current directly proportional to potential. This is called Ohm's law. So, how you can state Ohm's law? At a constant temperature, the condition is that the current flowing through the conductor directly proportional to potential difference. Don't forget it. Current is directly proportional to potential difference. That is called Ohm's law. So, from the Ohm's law, we can have so many ideas. From Ohm's law, I proportional to V. So, in order to remove the proportional design, I have to add one constant 1 by R into V. That is intelligent of Ohm. Simply we are putting R. R not in the denominator. He took the proportionality constant as 1 by R. R. Here R is a constant known as resistance. So, from this we can arrive V is equal to IR. This is from Ohm's law. Or R is equal to V by I. We can able to find out R. This resistance can be calculated by using the formula V by I. What is called V? Potential difference. I, current. So, ratio of these two will give R, resistance. So, these are all given in the thing. Ohm's law, I proportional to V, or V is equal to IR. R, resistance symbol. So, we have to find the difference. This is R is the resistance symbol. The unit of resistance is Ohm. This is the Ohm symbol. Be careful. Ohm. This is not a symbol for Ohm. So, this is a thing we know as far as a God symbol. But it's here the Ohm symbol is just like that. This is called Ohm. So, you have to keep your mind. This is the symbol for resistance. This is a symbol for Ohm. So, here I have given two graphs. Kindly observe the graph. So, from this graph, what do you infer? One graph, I get a proportionality curve. That means I got linear curve. Otherwise, it is called straight line. If a curve is drawn by taking current in the y-axis and potential in the x-axis, a curve as shown in the figure is got. So, this curve is called ohmic circuit curve. What is ohmic circuit? Any circuit obey Ohm's law is called ohmic circuit. So, whenever we are getting a linear curve or straight line, that means whenever the potential difference, the current increases, potential difference also increases. I proportional to V. That is a periodic increase. Be careful. That is Ohm's law. So, from the Ohm's law, it is clear that whenever you are increasing the current, the potential difference also increases. So, what about this curve? So, here the same graph can be drawn by taking current in the y-axis, potential difference in the x-axis. Instead of I got the linear curve, I get a curve like that. Have you seen this type of curve anywhere? So, in 12th standard, we are going to do so many experiments in electronics. The first experiment by using diode. So, there is a graphical representation of resistance by using diode, and also we know the variation of resistance with the current or potential difference. We have to find the input resistance or output resistance, impedance, everything by the way of curve. So in those, whether it is diode or transistor, we are getting a curve, not linear. So whenever you are getting a curve, not the linear curve, we are having curve as shown in the figure, definitely doesn't obey Ohm's law. We cannot expect it is Ohm's law. We cannot expect I is directly proportional to V. But I varies, V also varies, that's all. So here also we are finding the resistance. Here the resistance is called ohmic resistance. Because R is equal to, just now we have seen V by I. So we also did our experiment in 10th standard, I think so. Verification of Ohm's law. Simply the last column, V by I always constant. So here also V by I is a constant. Therefore we are getting linear curve. Those curves are called ohmic circuit that obeys. So your transistor or diode, they won't obey Ohm's law. So you are getting curvature. So here also resistance we can calculate. That resistance R is equal to delta V by delta I. Change in potential by change in current. So this resistance is called dynamic resistance. Be careful. Dynamic. So any circuit which doesn't obey Ohm's law, we can able to find out the resistance. Though resistance is called dynamic resistance. Here resistance also changes. Whereas any circuit which obey Ohm's law, we are getting a straight line from which it is clear that we are getting the resistance constant value. No change in the resistance. So that resistance are called ohmic resistance. That is a difference we have to find. Very important difference. And also this is a central syllabus. Then another thing we have to, from the resistance, we know the symbol resistance. Symbol is R, unit to ohm, everyone knows. The reciprocal of resistance, 1 by R, is called G, is called conductance, C-O-N-D-U-C-T-A-N-C-E. What is conductance? Conductance is nothing but reciprocal of resistance is called conductance. The name, the word itself there, you need not confuse yourself. Reciprocal of resistance called conductance. Symbol may be G. So unit, that is 1 by ohm. So 1 by ohm, otherwise ohm power minus 1. So another experimental unit is mho, MHO. That is also available unit, the reciprocal of resistance. Similarly, everyone knows the resistance of a conductor is directly proportional to the length of the wire and inversely proportional to area of cross section. The important thing you have to keep your mind. So many questions or so many problems, whether it is direct method or some shortcut method, definitely one problem comes in your NEET examination. If you are concentrate this idea, we can able to find out. What is the thing? The resistance of a conductor is directly proportional to length and inversely proportional to area. That is the thing. What does it mean? If you are having a long wire, if you are having a lengthy wire, it has a resistance low. If it is a short wire, it has more resistance. Similarly, if you are having a thick wire, very thick wire means area of cross section is more. It has less resistance. You should not imagine since the wire is so thick, sir, since it has more resistance. That is a wrong concept. Generally, we know if A is more or is less. If L is more or is more. That is the thing we have to understand it. So now to remove this proportional design, usually you have to add one constant. That constant is called rho, L by rho. Here rho is a constant known as specific resistance. SPECIFIC. Specific resistance or resistivity. The another name given, resistivity. The specific resistance or resistivity. This is the thing we have to understand. Then what is called rho now? The specific resistance or resistivity rho is equal to RA by L. This is the formula for finding specific resistance. RA by L. R into A by L. For A is area of cross section. We can put as pi r squared, L everything. There is a thing. Now what is the unit of resistance? We know ohm. Area meter square. by meter. So meter getting cancelled. So the unit of specific resistance is ohm meter. The unit of specific resistance is ohm meter. The specific resistance. So if somebody question me may ask, if resistance is more, what about the rho? Immediately your answer is rho is also more. That is wrong. Because resistance alone depends upon length and area. Rho does not depend upon length and area. Be careful. If you are changing A and L, R may be changed, but rho won't be changed. So rho does not depend upon length and area. Then rho depends only on material of the wire. So make it understanding or take it by underline. The specific resistance or resistivity always depends on what factor? Only material. We need not bother about the length, size, area, everything. We least bother about it. It depends only on material of the wire. That is, keep your mind. Why I am telling repeatedly, we have to solve so many problems here. We have to keep. Because rho is equal to RA by L. So this is the thing we have to understand it. So from this specific resistance, what is resistivity? Conductivity. Conductivity. Sometimes the question may be asked. Calculate the conductivity. Conductivity. Conductivity, symbol sigma. Conductivity sigma is equal to 1 by rho. That means reciprocal of resistivity, conductivity. Reciprocal of resistance, conductance. Both are same. So here resistance, conductance. Here resistivity, conductivity. Calculate the conductivity means we have to find the reciprocal of resistivity that will give conductivity. Unit 1 by rho. That means 1 by ohm meter or ohm power minus 1, meter power minus 1 or mho meter power minus 1. This also we know mho meter power minus 1. That is also possible. So why I am telling this idea, be careful, this formula RA by L. So from this it is clear that, so we have to concentrate more about this problem. This is a problem oriented. One time I think so, the year 2005 I think so, one problem asked in +2 public examination. That is not, be careful. If the length of the wire is 10 centimeter and its resistance equal to 2 ohm. The length of the wire is 10 centimeter and its resistance is 2 ohm. What is the question is asked? If the length of the wire increased by 50 centimeters, what is its resistance? What is its resistance? So this is the problem asked in the section A. The length of the wire is 10 centimeter and its resistance is 2 ohm. If the length of the wire is increased or stretched by 50 centimeter, what is its resistance? So most of the students, they put the answer 10 ohms. Because 10 become 50, 2 become 5 into 2, 10. So what are the physics here? So we leave it this problem. Now we have to consider for understanding. We know the resistance or specific resistance formula RA by L. So here the problem is concerned the same wire. One wire is stretched, that's all. We are not taking two different wires. Because it is same wire, both the wires are having same material. Since it has same material, their specific resistance will be the same. That is a concept I want to take. That means R1, A1, L1 must be equal to R2, A2 by L2. That is also equal to rho. Because if you are changing the length or area, what happened? The specific resistance will be the same. The specific resistance depends only on material of the wire. Once we arrive our syllabus, we have to use this type of steps. So another thing you have to concentrate it, if the length of the wire is increased 10 to 50 centimeter, be careful, kindly attend the class. So if the wire extended, therefore length may be increased. If length increased, what about the cross-sectional area? Decrease, because thinner and thinner. When length increases, area decrease. So there is a change in length as well as the area. If you are simply 10 ohms, answer means you are taking only the length, you are forgetting to take the change in area. So we have to take a concentration about the change in area also. So that when length increases, automatically the area decreases. Then what is the area into length? That will give volume. Volume remains constant. Be careful, volume constant. So we have to understand about this circular problem. Why I have explained this, any type of problem, directly we can substitute, we can get the answer. How? If length alone be increased means area decrease. First concept. Length changes, area changes, but volume remains constant, and also specific resistance depends constant. Because specific resistance or resistivity depends only on what? Only material. So, okay. Therefore, what is the first wire before extended? Its volume. That is length into area. That is always equal to L2 into A2. So here area less, length is less, area more. Here length is more, area is less. Therefore the product will be the same. That means volume remains constant. Therefore A1 by A2 is nothing but L2 by L1. So you have to keep your mind. So there we have to take this, the thing, R2 by R1 is equal to, from this step, R2 by R1 is equal to L2 by L1 into, so you have to keep L2 by L1 into A1 by A2. So from this step, L2 by L1 is also A1 by A2. This A1 by A2 can be replaced by L2 by L1. Therefore, R2 by R1 is equal to L2 by L1 the whole square. So this is the formula I have arrived. These are so many steps we have to involve. For one more question, just imagine, as far as our syllabus is concerned, we have to use so many steps. So L2, now you can imagine, what is the value of L2? 50 by L1, 10, 50 by 10, what happened? That is 5 squared, that is equal to 25. Therefore R2 is equal to 25 into R1, that is 2, that is equal to 50 ohms is the correct answer. Be careful. So if we are using so many steps or so many theoretical concepts involved, what you arrive for the NEET examination. If you are asked this type of question, you need not worry about it. From this it is clear that this L2 by L1 may be taken as n, therefore n squared. Therefore I get the R2 is equal to n squared R1. This is the formula I got. That means new resistance equal to n squared into R1. This is the formula taken from me. The new resistance is equal to n squared into old resistance if the wire is extended. Be careful. So reverse problem. If 10 centimeter wire is 50 centimeter, what is n? N is nothing but how much it is increased? 5 times. Therefore simply we can put 25 into old resistance to 50. Directly in a single line we can get the answer. We need not go for so many steps. So that is the advantage of NEET examination. So you have to keep your mind, what is the wire if it is extended. In order to find out the new resistance, the formula is n squared into old resistance. Be careful. Or sometimes the question may be asked in the reverse direction, what happened? If the length of the wire is 50 centimeter, its resistance is 50 ohm. This 50 centimeter wire may be contracted to 10 centimeter. Then what is the new resistance? So if the question is asked, then R by N squared is the formula. Or R2 is equal to R1 by N squared. R by N squared. That is the wire which are contraction. Wire which are extended N squared R. So you have to keep two formula. One formula N squared R for the extension. Another formula R by N squared for contraction. So here R, the 50 centimeter wire, 50 divided by N squared, contracted to 10 centimeter, 5. 5 squared, 25, 50 by 25, 2. The reverse problem comes. So you have to keep your mind, as far as the Ohm's law, the resistance problem is concerned, regarding specific resistance, when the wire is extended, its specific resistance is same. Even if the wire is contracted, its specific resistance is same. Only specific resistance depends on material. When the wire changes its length, its area also changes, but the volume remains constant. So many ideas you have to keep your mind. If the question is asked, if the wire is extended, you have to use the formula N squared into R. If the wire is contracted, we have to use the formula R by N squared. This is an important topic you have to keep your mind. These are all the things I have given in the slides. Be careful. K is called current density. The current density is a new formula I have given here. Because conductivity sigma is equal to 1 by rho. We know current is equal to V by R. Isn't it? So here I have to change everything. What is E? What is the difference? I by rho I by A. Or keeping I by A here, sigma 1 by rho is called sigma into A. So it is called I by A. I by A is called current density. Another formula for current density is sigma into E. So how can you find that? Simply sigma. Sigma is called 1 by rho. That is 1 by rho into E. What is rho? Specific resistance. Specific resistance, we know the formula RA by L. So here L by RA into E. Am I correct? So many concepts we have to introduce it. So another formula you can able to find out the current density, that is RA. But E is nothing but V by L. Therefore L by R A into V by L. So this LL may be getting cancels. V by R. Again current I by A. Therefore charge density is nothing but I by A. So be careful. This is a reverse formula. So we can have the two formula. The current density means current acting on unit area I by A. So how it comes? R E by rho. That is another formula. E by rho. Or E into sigma. Whatever may be the thing, how it comes. So these are the so many involvement in the problem is concerned. That is the thing we have to understand it. Then what are carbon resistor? This is an interesting one. So usually resistor have a length in size. So every resistor loaded in a particular circuit, it occupies large area. Therefore the circuit are also bigger. Therefore any instrument we are constructing is also big in size. That is a problem. So that the carbon resistor was introduced. The carbon resistor is a smaller in size, which has compact and cheap, maybe 50 paisa or 1 rupee. Carbon with a suitable binding agent is molded into a cylinder. Is molded, M-O-L-D-E-D. Molded into a cylinder. By heating. We are taking a carbon and some binding agent molded by heating, they form a carbon resistor. The carbon resistor has a color code from which we can able to find out what is the value of the resistor. So suppose this is a resistor given, the first color will give the digit, the first two, another two lines are called a multiplier, the third color is called tolerance. Tolerance means we can have some error, that is the thing. So how can you find the values? The value can be keep your mind by the word B.B. Roy, Great Britain, very good wife. B is not Y, it is V. VGW. B.B. Roy, Great Britain, very good wife. That is for understanding. Just in mathematics also, all silver teacups, like that. If B means black, we have to put a 0, brown 1, red 2, orange 3, yellow 4, green 5, then blue 6, violet 7, grey 8, white 9. So suppose the last tolerance given as 5, gold color. If it is gold color, 5% tolerant. If it is in silver color, 10. No color means 20%. That is a more difficult value. If it is in golden color, the last color we can have. I can give an examples also in this slide. Color for the rings on the resistors are given us. The colors are yellow and brown. So kindly go. That is yellow and brown. Yellow has number 4, brown has number 6. Be careful. That is given 46. The third one is called, what is the thing? The third line is called multiplier. The multiplier means 10 to the power of something. Because the next color given in the problem are yellow, brown and gold. What is called gold? Tolerance is 5%. 5%. That is, brown has the values of 46 follows with the 30. Therefore, 46,000 or 46 into 10 cube ohm. Variation of resistivity with the temperature. We will see later. So this is the thing we have to understand about carbon resistor. Color of the resistor example are yellow, brown and O, orange. So this is hidden. Y, O and B. Therefore Y for 4, brown for 6, orange for multiplier. Multiplier means 10 by 3, 10 cube. That is 10 power 3. 10 cube is called multiplier. Or orange follows with the 3 zeros or 46. Orange number is 3. Therefore 46 in 3. Since we are giving golden color, the tolerance is 5%. This is the thing we can able to find out the resistance very easily by using the formula. That is B.B. Roy, Great Britain, very good wife. Substitute the value. If you are given a color code, by the use of color code, we can able to identify what is the value of carbon resistor. So another topic is called the resistivity with temperature. Variation of resistance with the temperature and variation of resistance with the material. Everything we will see in the next class. Thank you.